Hello again, this is Dr. Caleb Chen, and we're going to continue on with another example of calculating the normal probability using the information. The example again is on IQ score distribution with a mean of 100 and the standard deviation of 10. We have been utilizing the standard normal equation. Z is equal to x minus mu divided by standard deviation. And we have also looked at how the areas under normal table curve, normal curve at the back of the textbook can be utilized to help us approximate the probability without using calculus. So I have another scenario, and this time with both of the two values they're on the same side of the distribution, and so what's the probability that we'll find a student whose IQ score is between 110 and 125? So we plug the numbers in. 110 minus 10 minus 100 divided by 10. We will 10 over 10 is 1. And IQ, because while we're converting the number into Z score, so IQ becomes Z here. And just to keep the notation strict, 125 minus 100 is 25 divided by 10 is 2.5. So we have 1 and 2.5. Both are on the same side of the equation or of the curve. So if we quickly sketch something, I wish I have a bigger whiteboard, but bear with me. So 0, and then is 1, and then 2.5. So basically the area under the curve is right here, and we're no longer adding the two areas together. The area here is from 0 to 1, that we know based on the previous calculation is equal to 0.3413, and from 0 to 2.5 all together would be equal to, say, 2.5, and I believe it is equal to the 4938, so 0.4938, which represents that from 0 to 2.5. What we want to know is what is from 1 to 2.5. If we already have this piece from 0 to 1, which is 0.3413, so the answer to the question should be is equal to 0.4938 minus 0.3413, because this shaded area is the difference between the bigger area, which is 0.4938, and the smaller piece, 0.3413. So if we do a little bit of subtraction here, I believe we have 0.19 minus 4 is equal to the 5, and is 25. 0.1525, which is this area shaded, and is the difference between the bigger probability and the smaller probability. And as a rule of thumb, when you have two probabilities that you need to be calculating, you're not certain whether you should be adding them or subtracting them. Well, look at the graph here, and if it's all on one-sided, it's always taking the smaller probability, subtract that from the bigger probability. Since probability has to be between 0 and 1, you cannot have negative anyway. And the reason why we're not adding them together is because both Z values 1 and 2.5 are on the same side. Had they been minuses, we'll do the same thing, because the normal probability curve is the left-hand side is a mirror image of the right-hand side. So hopefully it helps you to understand better on the normal probability distribution and how we do some calculations based on a couple of parameters given to us.